Okay, I think somebody's in and out, but yeah, cool. Anyways, let's make a start. So it says here is a trapezium ABCD. The area of the trapezium is 66 centimeters squared. So straight away, when I look at that sentence, right, we've seen these questions all the time. They tell us the area of something, and then we need an algebraic expression for it and make it equal to 66. Blah blah blah. Same thing, right? And it says the length of AB to the length of CD is 2 to 3. Find the length of AB. Okay. So first things first, they've told us that the area of the trapezium is 66. So can somebody tell me, well, to answer this question, we know we're going to need to use that at some point. Can somebody tell me the formula for the area of a trapezium, please? What is the area of a trapezium? Do we know it? Okay. Remember, we have A here, we have B here, we have the perpendicular height. The formula for the area of a trapezium will just be A plus B times by H divided by 2. No? Do we not remember that? Yeah? All good? Okay. So we know we're going to need to use that somehow. Now let's look at the question, what they've said. So this will be our A, right? This will be our B. And we have this perpendicular height here, don't we? Yeah? Or we could do the other side, but this side will obviously help us. Yeah? Okay. It says that the length of AB, right? The length of AB, right? To the length of C to D, right? Which is this one here, is in the ratio 2 to 3, right? So remember, we do not know these heights, do we? But they've given it to us, or we don't know these lengths, sorry, right? But they've given it to us in a ratio. So for example, an example of this one will say, well, this, if it's in the ratio 2 to 3, an example will be, for example, the length of 2 and the length of 3 centimeters, or it could be another value in the length in the same ratio 2 to 3. So for example, I could say 4 to 6, yeah? Or I could say, for example, I don't know, 6 to 9, and so on and so forth. Do we agree that these are all in the ratio 2 to 3, right? If I divide this by 2, I get 2 to 3. If I divide this by 3, I get 2 to 3. So what you could say is that algebraically speaking, we could write the lengths as, for example, right, this is 2 times 1, 3 times 1, right? This here is 2 times 2, 3 times 2, and this one is 2 times 3, right? 3 times 3. So can you see all of these are multiples of 2? This is a multiple of 2. This is a multiple of 2. This is a multiple of 2. And this here is a multiple of 3. This is a multiple of 3. This is a multiple of 3, and so on and so forth, right? So that means I can say, well, the length, algebraically speaking, right? Could somebody tell me what I could say the lengths are? Algebraically speaking, what do we think? If they're multiples of 2, how could I express the lengths in an algebraic sense? What do you think that would be? It'd just be 2x, wouldn't it? Right? And this would be 3x. Does that make sense, guys? Yeah? We could say that the length of AB would be 2x. I'm going to call this 2x. And I can say this is 3x. Yeah? Does that make sense so far, guys? This is the important part. I'm going to make sure we're all okay with that. Does this make sense? Yeah? Okay. Cool. Cool. So I'm going to assume that we're all okay. I'm going to continue, right? Now, it tells us that the area of the trapezium is 66. So definitely we need some sort of expression for the area, right? Which is A plus B times by H, right? Because of this formula, meaning that we need to figure out what the perpendicular height is. And we've got this here. This here, we could say, well, this must be a right angle triangle, right? So I could say, if I draw a right angle triangle like this, draw a right angle triangle like that. And then I need to, let me just do it so it's upright, to be fair. So like that. Yeah. Okay. This is 30 degrees. This is 30 degrees. This is 6 centimeters. This is a right angle, clearly, and this is H. Yeah. I need an expression for H, don't I? Or I need to figure out what H is, not an expression, because we could figure it out. How do we do this, guys? What topic is coming to mind? When I see a right angle triangle, I can see an angle there. I know one of the sides, I'm looking for another side. How do I do this? Exactly. Thank you very much, Jimmy. Trigonometry. What specifically in trigonometry? There's a lot of things that you can do in trigonometry. There's half A, B sine C. There's the sine rule. There's the cosine rule. There's SOHCAHTOA. What specifically in trig do we need to use? What do we think, guys? This is a question for everyone, by the way. Give a few more seconds. Okay. Well, whenever we have a right angle triangle and we're dealing with trig, we're using SOHCAHTOA, aren't we? Yeah. So we need to use SOHCAHTOA here. Okay. Now, what do we have? How do we use SOHCAHTOA? We label our right angle triangle. I have the angle here. I'm going to draw a line opposite the angle. The side that takes me to would be the opposite side. So I'm going to put this as opposite. Now, this side obviously is clearly the hypotenuse, right? And obviously the side is the adjacent. Now, remember, how do we do SOHCAHTOA? We're looking for a length here. So we're going to highlight the side that we're looking for, which is H, and this represents the opposite. And we also highlight the other side that we're given, which is a 6, which is the hypotenuse. Yeah. Therefore, we would use the opposite and the height, wouldn't we? So can somebody tell me which one will we use out of SOHCAHTOA and TOA, please? Very quickly. Which one do we use? Exactly. Thank you very much, Tony. We use SOH, right? Because we have the opposite, we have the hypotenuse here. What does this mean, though? This means that the sine of the angle, whatever the angle is, right, is equal to the opposite divided by the hypotenuse, isn't it? Yeah? Now we can plug in everything that we know. We have the sine of 30 degrees is equal to the opposite side, which is H, which is what we're trying to find, divided by the hypotenuse, which is 6. Meaning that to get H, right, we just times both sides by 6, isn't it? We could say 6 times the sine of 30, right, is equal to H. Okay? Now, this is no problem if we had a calculator. This is a non-calculator paper. So does anybody know what the sine of 30 is? Do we know our exact trigonometric values? Does anybody know? Okay, no worries. What I'm going to do is I'm going to get, there's a sheet that I have. Where did I put? I think it was here. Let's check. Yeah. This is your exact trig value. So you need to memorize this for your exam because it's not given to you in the formula sheet. There's a way to remember it. I can't remember how you do it. I think you do square roots or something like that. But I'll see if I can find it maybe in the lesson. Yeah. But this is your trig table. You need to know all of these off by heart. There's a way to remember it. I just forget how they explain it. But yeah. So I'm going to put this here. So obviously in the exam, you're not given this. You need to have this in your head. Yeah. So obviously we can see that the sine of 30 is 1/2. Yeah. So therefore we can say that we've got 6 times 1/2, right? Which tells us that the height is 6 times a half, which is just 3, isn't it? So therefore we can say that the height is 3. So now we have this here. We could say H is equal to 3 here. Yeah. Perfect. Now we're in business now because the question told us that the area of the trapezium is 66 centimeters squared. We now have all the tools we need to create an expression for the area of the trapezium, right? Remember, it was this formula here. I'm going to copy this here. Copy here. So we have this here. And then remember, we can see clearly that A is 2x and B is 3x. So I'm going to say, for example, A is equal to 2x. B is equal to 3x, and our H, the perpendicular height, is the value that we found here, which was 3, wasn't it? Yeah. So we've got this here. So therefore, the area of the trapezium, we're just going to plug in everything that we know. So it will be A plus B, so 2x plus 3x, right? Divided by 2, right? And obviously, we're going to times by 3, aren't we? Yeah. And then we know that this area here, this area is 66, isn't it? Because they told us right here. Yeah. So we've got this. Okay, now we can figure out what x is and then times it by 2 to give us the length that they're looking for. Yeah, the length of AB, 2x. So we're looking for 2x. Yeah, okay. So that's fine. Well, what we can do now is we'll say, for example, we've got 5x here. 2x plus 3x is 5x. We've got times by 3, which would be 15, over 2 is equal to 66. Now we can say, for example, we have 66 times 2. So let me do this. We've got 15x here. And then we've got, this is equal to 66 times 2, which is 132, I believe. Right? And then can this simplify? It can do, because this will have 6. Okay, so yeah, the answer is 132 divided by 15, whatever that is. Can this simplify? Well, I know, imagine I'm in an exam. I could either use the bus stop method, or I could say, well, I could just try and break it down in terms of factors. So I know, for example, 132 is the same as 66 times 2. Yeah, because we just times it by 2 to give us that. And this is 15. And then, for example, I could say, well, 66, right? I can break this down in terms of 3s. So I can say this is the same as 3 times 22, right? All over. And then this is 3 times 5, isn't it? Yeah. And then now 15 is 3 times 5. That's fine. I've broken this down. This will cancel like this. And then this will just become 44 divided by 5, right? So therefore, this is x here. X is equal to 44 divided by 5, right? So now, therefore, we have 2x, which is what we're looking for. 2x will equal 88 divided by 5. Yep, and you can leave it as a fraction. Does that make sense, guys? Trying to make sure we're all okay with that just before we continue. Yeah? Or you could put as, you could do the bus stop method and write it as a decimal. But does this make sense? This is the answer. This is 17.6 as a decimal. Yeah? But either one is fine. You can put it as a fraction. Does that make sense, guys? Trying to make sure we're all okay with that just before we continue. Yeah? Remember, you could use the bus stop method to do this as well. I just did this because I just find it easier to just break it down and find different factors. Yeah, when I have large numbers. Yeah. Just gonna give a couple of seconds. We all okay with that? Anybody want me to go through anything again, or is that all clear? Let me just run through it one more time, just so we just understand what's going on here. You had a trapezium. They were asking us for the length of AB. We didn't know what that was, so we needed to express A and B algebraically. Since it was in the ratio 2 to 3, we therefore said that A would be 2x, B would be 3x, and then obviously we need the height, because obviously we need the area of a trapezium, which is A plus B times h over 2. We needed to create a right angle triangle to get what h is, using trigonometry. And yeah, we got h equals 3. We plug h equals 3 into here. Yep. And then we just algebraically manipulate, simplify, blah, blah, blah. And we get 88 over 5 or 17.6 as our answer. Yep.